Okay. So I'm going to be talking about what I've been working on. So this is the disk and memory effects of branch buffer size limits on DAOD production. But first, I want to briefly talk about the traineeship that kind of helped me into this program. So C squared, the P squared, or the Chicagoland Computational Traineeship in High Energy Particle Physics, is a traineeship that takes physics and computer science graduate students and pairs them with mentors based Argonne and Fermilab, who are affiliated with the various experiments in high energy physics, and it helps prepare them to become the next generation of computing researchers. Along the way, they end up getting the trainees get earn a master's degree, and in my case, I became an Atlas author through this qualification task. So let's talk a bit about derivation jobs. Um, Derivation jobs are jobs that take reconstructed data, so AODs, and turns them into derived analysis object data, which are a file that which are root files that are used for analysis. And in this process of creating an AOD, DAOD, we end up seeing some memory limitations and some IO limitations. And that's something that we want to kind of figure out how to mitigate in for the future of computing work. DAODs take on a couple different forms for Atlas. Fizz and Fizzlite are the popular ones. I think for CMS it's going to be Mini AOD and Nano AOD. And the goal is to get from a very large AOD to a much smaller DAOD with the kind of order of per event being from like 1 MB to about 10 kilobytes. And these files are generally still pretty large on the order of a handful of gigabytes, but it's still a lot better than just taking AODs. But there's also some refinement along the way as well. So how can we reduce the load to the grid? Um, One way we can kind of look at it is through optimizing these branches that we have, either on the root and or on the Athena side of things. And um, one way that it's been done in the past is by creating this 128 kilobyte branch buffer limit, in addition to a minimum number of entries. So we limit it to 10 entries, or um, set the minimum number of entries per buffer to 10. And this is something that we wanted to make sure, like, is this the right optimization? Um, and that's what we kind of look into. So let's start with a bit of a toy model, just to kind of see the original motivation was to see if 128 kilobytes was the best for memory and disk usage. And so what we end up finding in the toy model, where we fill a branch with some fraction of random floating point numbers and compressible integers, and just to mimic what data would look like. And we wanted to see, how does the compression factor change based on the basket size. And so after a couple different tests of setting the basket size to 38 kilobytes, 128, and so forth, we see this kind of plateau effect after 128 kilobytes, and we start to see something like diminishing returns possibly afterwards. And so this is something that, we wanted to make sure, like, okay, how would this look like with real, like, data and Monte Carlo simulation? But another question we had was, how would this look um, when we changed it both in root and in Athena? So we looked at that, and simply from the toy model, it seemed to be the case that we really only needed to look at Athena for this, because it seems that root optimizes buffers pretty well, so let's just leave it be for now. So when we were going to test data and MC derivation jobs, we wanted to just limit our testing to changing Athena only. So this is what we're going to be looking at. And um, what we essentially kind of boiled it down to was looking at, again, this integration of 128K basket limit and the minimum number of entries. So we looked at both the presence and non-presence of each of them. And for data, we didn't really see much of an effect. It's a little, you can kind of see it in the memory, but what we really find interesting is what happens with the Monte Carlo derivation jobs. It sees a much more exaggerated effect, and we can reduce the file size, but only at the expense of the memory. So what we're looking at here is where we have the basket cap present, but when we get rid of it, it seems to cancel out the effect at first order, which is kind of funny because the integration of both the basket cap and the minimum number of entries was implemented at the same time, and we didn't really see this effect separately. But now we're able to see them separately and see how, choosing 128 kilobytes for the basket limit and the minimum number of entries kind of hits a happy medium. So that was pretty nice. So how good is choosing 128 kilobytes? It's pretty good. What we can do is, increase that up a bit and see just how much of an effect between 128, 512, and no limit, which really means 1.3 megabytes for the basket limit because that's what root sets it at. Um, and we see obviously it's going to have like a much larger effect on the memory, but it doesn't scale as nicely for the decreasing output file size. So some interesting branches that kind of emerge from this testing, specifically in the MC Fizzlight files. Um, One of them is this HLT nav summary that we see does in fact hit this kind of 1.3 meg basket limit. Um, and the compression factor doesn't go up a ton, which is kind of what we expected from what we saw with the toy model. But we also see these like very large compression branches. One of them being the primary vertices, Oxton track particle lengths, and um, these are just a couple other hand-picked high compression branches that might be worth looking into a little bit further. Um, what we did look at were, it's so this one is kind of filled with mostly empty values, so ran like normal integers, mostly zero, but the other ones are these highly compressed like hard scatter vertices and tau track links, which we're not really sure why they're very compressible. I'm assuming they also have a lot of repeated values that don't really need to be there or really need to be this large to begin with. Um, so maybe that's something to look into. And yeah, and again, just the HLT nav summary. That's another one that we were interested in. So to conclude, removing the basket limit does decrease the derivation jobs output root file at the expense of greater memory usage. But whatever we're doing, what we have right now is good. So and looking at these highly compressible branches, we can maybe try and look into it a little bit just to see what further cuts we can make to make derivation a little bit easier. So with that, I wanted to include a little bit of some NIU representation and Hopefully the projector picks it up. Okay.